So welcome to another lecture. In this lecture, we'll be doing basics of ionic bonding and covalent bonding. So these are the two bondings, two kind of bonding that we'll be studying in this lecture. See, my intention is to make both these kind of bondings as easy as is possible. So basically, this is a very beginner friendly. I'll try to make this a very beginner friendly lecture. But before I start this lecture, uh, there is an assumption that I have. The assumption that I have is that you know how to write the electronic configuration. At least you should understand how to write the electronic configuration of the first 20 elements. If you are not okay with the electronic configuration, I'll suggest to have a look at one of my lectures. I'll put the link here. You can have a look at that. If you have any doubt, otherwise I have taken this PDF where all the electronic configuration is there. So just refer. Specifically, these are the elements which I have ticked. I'll require these. I'll take you through these uh, because these are the elements that I'll be using for the bonding purpose. So hydrogen atomic number is 1. So electronic configuration is 1. Very simple. Lithium atomic number is 3. So electronic configuration would be 2 comma 1. Carbon, it is atomic number is 6. So the configuration that we'll have is 2 4. Nitrogen, it is 7. So electronic configuration is 2 5. For oxygen, 8 2 6. Fluorine, 9. Atomic number is 9 2 7. Sodium atomic number is 11. So 281. Magnesium, 12. So the electronic configuration is 282. These are the examples. These are the elements that I'm taking because I'll be using them in chemical bonding. So I just want to take you through these first. So chlorine 17287, calcium 202882. So you should be okay with writing the electronic configuration of all these elements. So once we are done with this, there's a second simple thing that you need to understand is that, see, what does a element aspire for? So basically, the element aspires for a inert gas electronic configuration. I'll write it here. Inert gas electronic configuration. So what is the meaning of inert gas? Now I hope you know that helium atomic number 2, neon atomic number 10, argon atomic number 18. So the in the first 20 elements, these are the the first three, we can say, in the periodic table. These are the first three noble gases that we have, and the elements in the first 20 elements want to be like them. So what I'm trying to tell you here is that hydrogen will love to have a electronic configuration like 2. So it will like to have one more electron because it only has a electronic configuration of 1. It will love to have a configuration like 2 electrons in the outermost shell. Similarly, lithium will like to have a configuration of something like this 2. So basically, what lithium will aspire for is to lose this one electron, because if it loses this electron, it will have a electronic configuration of the nearest noble gas. I hope this is making some sense. Then we take example of carbon. So carbon 2 4. What does it aspire to be? It aspires to have an electronic configuration something like this of neon. So what it wants is that if it can have 4 more electrons in its outermost shell, it will be very happy. Again, nitrogen 5 electrons, it will aspire to have 3 more. 6 oxygen, it will aspire to have 2 more. It will aspire to have 3 more. Fluorine, it will aspire to have 1 more, so that they can get an electronic configuration of neon. Now, why do they want to have an electronic configuration of the noble gas? Because it is seen that the noble gases are very stable. Stable in the sense that they are not very reactive. They are like they are at peace with themselves. So, in humans also, we want to have a very stress-free life. We want to have a very peaceful life. So elements also want to aspire to have a very peaceful, a very stress-free life. So they have seen that these noble gases, they have a very stress-free life. And that is a loose example that I can take. So the elements aspire to have the noble gas configuration. I hope you are with me till here. Now, if we take the example of sodium, it wants to lose one electron. Magnesium, it wants to lose two electrons. Aluminium, it wants to lose three electrons. So that it can have a configuration like neon. Similarly, if we come on this side, so for example, chlorine, 287. Now, see, the logical thing for chlorine to do is get one more electron so that it becomes 288. Because losing 7 electrons and becoming something like neon would be very difficult. So losing 7 electrons is very difficult. Doesn't make sense. It would chlorine would rather have chlorine would rather get one more electron and have a configuration like 288. Similarly, potassium 2881, it will rather lose this electron. Calcium, it will rather lose these two electrons so that they can have a configuration of the nearest noble gas, which is Argon. So let's review what I have discussed till here. What I have discussed till here is that in the first 20 elements, because we'll be discussing about the first 20 elements in this lecture. So in the first 20 elements, there are three noble gases: helium, neon, argon. Now, what is found in nature is that helium, neon, and argon are very stable. They are at peace with themselves. They are like saints of a human in the human world. So we have like saints, saints who are very peaceful. So all of us want to be like those saints to live a very stress-free life. So that is what the elements also aspire to be. So for example, I have taken the example of lithium. Lithium wants to be like helium. If you look at electronic configuration, beryllium, it wants to be like helium. Boron, it wants to be like helium. Now lithium, beryllium, boron, how can they be like helium? They can be like helium by losing 1, 2, 3 electrons. Nitrogen, oxygen, fluorine, how they can be like neon? They can be like neon by gaining 1, 2, 3 electrons. Hope this is making sense. Sodium, magnesium, aluminium want to be like neon. How can they be like neon? They can be like neon by losing 1, 2, 3 electrons. Uh, Potassium, calcium, how can they be like argon? They can be like argon by losing 1 and 2 electrons. Yeah. So phosphorus, sulfur, chlorine, they want to be like argon. They want to be like argon by losing, sorry, by gaining 1, 2, 3 electrons. So that they have a what would be written in your book is a octet configuration. Octet configuration. Octet implies 8. 8 implies 8 electrons in the outermost shell. So if I rub all of this. Now, what does the octet configuration means? So, for example, if potassium loses one electron, it will have 8 electrons in the outermost shell. Calcium, if it loses 2 electrons, it will have 8 electrons in the outermost shell. Sodium, by losing one electron, would be 2, 8. Magnesium, 2, 8. Aluminium, 2, 8. They'll have 8 electrons in the outermost shell and they'll have a octet configuration. They will resemble something like neon, the nearest noble gas. Similarly, uh, lithium, if it loses 2 electrons, it will have 2 electrons. Here, octet is not there, 2 electrons in the outermost shell. Again, 2 electrons in the outermost shell. 3 electrons, if they lose 3 electrons in the outermost shell, they will become something like the nearest noble gas, which is helium. See, for lithium, beryllium, boron, the nearest noble gas is helium. So they will try to be like helium. They see, please try to understand the logic. See, for lithium to gain 7 more electrons and become something like a neon is very difficult. So it will rather lose this one electron and become something like helium. Similarly, for beryllium, it won't try to have 6 more electrons and become like neon. It is far more easier that it would rather lose the 2 electrons and become something like helium. I hope this is making sense, and you are with me till here. So, so this is what this is what the elements are aspiring to be like the nearest noble gas. And due to this aspiration, they try to form chemical bonds. When they try to form chemical bonds, they are able to get the nearest noble gas configuration. That is why chemical bonds are formed. And now what we'll study is that once we are okay with this understanding, now for formation of chemical bonds, two uh, of course there are few other things, other types of bondings also are possible. But here now in this lecture we'll be discussing only two types of bonding. One is the ionic bonding, other is the covalent bonding. But the intention remains the same, so that each element tries to be at peace, wants to live a stress-free life. So, for example, NaCl, both Na and Cl want to live a stress-free life. MgO, why does it form a bond? Wants to have a stable life. CaO, calcium and oxygen want to live a uh, uh, stress-free life. Lithium and chloride form a bond because they want to be stable. To find stability, they form compounds. And now, in the next part of the lecture, what we'll do is we'll try to understand how do they achieve the stability. Uh, so we'll be discussing the ionic bonding first, and then we'll be understanding the covalent bond.